Well, hello. As already flagged, we are starting Unit 3 with number sequences, Chapter 4 and 5. And then after about 5 weeks, we'll be moving on to bivariate statistics from Chapters 1 to 3, which will have the assignment attached to them. And then after that, we move on to graphs and networks in Chapter 6. So, Chapter 4, number patterns and recursion. This is what we're going to be talking about for the next 4 or 5 weeks. We'll learn about number patterns that are rule-based, and in particular 4 operations rule-based. I'll explain what that means in a moment. We will be describing these rules as arithmetic or as geometric, and generating them using something called recursion, or with rules or formulae which generate the nth term. Now this doesn't make much sense until it's enlarged upon. That'll happen in the next 4 or 5 sections of the chapter. So the learning intention for today is quite basic on that. Can you generate sequences using a calculator and describe the terms of a rule-based sequence using subscripts? So we're going to be learning the language of dealing with number sequences, mathematical language. This says 2 types of sequences. It's not really 2 types of sequences, it's 2 ways of describing sequences. We can have them randomly generated, which is just a random series of numbers with no relationship between them at all, or a rule-based one, where if you examine the sequence of numbers, you will see that there is a rule generating the next number. You'll probably see that it is adding 4 each time, starting with 1. The ... by the way, is technically called the horizontal ellipsis, and its purpose here is to say that the sequence continues after the numbers which are given. So the rule for this sequence, which we've already described informally, is add 4 to the previous number. And any rule, any sequence which is generated by using whatever the last number is or the current number to create the next number is called recursive. This is what makes a recursive sequence, changing the last number to provide the next number. And we're going to be using subscripts, which are the little 1, the little 2, the little 3 there. That's called a subscript as opposed to a superscript. And so what we read there is T1, T2 or T3, otherwise meaning first term, second term or third term of the sequence. So if I ask you by one means or another to find the 31st term of the sequence, I'll be asking you to find T31. That's just language. If I ask you to say what number 13 is on this sequence, you would say that it is T4. Now here are some other sequences. The first one we just looked at was adding 4. What's happening here? Well, I hope you can see we are adding 3. What about the next sequence? 66, 58, 50, 42. You had a bit of practice at this on the first day. Subtracting 8. Third one on the screen. 128, 64, 32. Next number is, I hope you will be able to tell me, is 8. That is because we divide 16 by 2. Dividing by 2. There are other sequences which have 2 aspects of them. In other words, there will be a multiplication or a division, and there will also be an addition or subtraction. So these are a combination of arithmetic and geometric. Now, there's one here on the screen, 2, 12, 42, 132. It might take you time to work out, but I think what I did here was I took a term, multiplied it by 3, and then added 6. So we times by 3, then add 6. Now whenever you think you've got a rule, you must check it for all the pairs of numbers on the screen. So we have to check 2 3s are 6 plus 6 is 12, okay. 12 3s are 36 plus 6 makes 42. 342 is 126 plus another 6 is 132, so it works. Now that may have been not too easy to see, but later in the unit you will learn how to discover that the rule here is multiply by 3 and then add 6. So we'll give you some ways of unraveling sequences. Now calculators come in very useful here, and I'm talking about scientific calculators, the ordinary green ones, or whatever brand you have, or graphics calculators. They will both do it. What you have to do on a scientific calculator, first of all, put the first number of the sequence in. You're always going to have a first number given to you. So 6 and then enter. Just put it in. And then the rule is a combination one, so we're going to multiply 3 and then add 4. If you press enter, the calculator will tell you 22. Now all you have to do at this point is press enter again, and it will do another times 3 add 4 and give you 70. Press enter again and it will give you the next number. 210 plus 4 is 214. Check it out. So calculators can be used to generate recursive sequences. They take the current number on the screen and then do whatever the operation is without having to put it in again. Quite handy. That's a scientific calculator. Graphics calculator, pretty similar, except that you have to, after putting 6 enter in, you have to then press the answer button, which is probably on the bottom right somewhere, times 3 add 4 enter, and then press enter after that, and you will get the same sequence, 6 22 70. So check out that it'll work for you on your graphics calculator as well. And that is the full wrap for exercise 4a, which is on page 100 of the textbook. And what we would like you to do is explore all the questions so that you can get ready for 4b. Thank you.